Here we're going to go over rotations and 5 different ways you can rotate. I'm going to show you how to use each of these 5 rules on this 1.3, -4. I want to be real clear though that you might be asked to rotate not just a point where you can come up with the coordinates of the point, apply the rule, and then you have the coordinates of the new point that you can plot. You might be asked to rotate a line, and in that case you need to come up with 2 points on that line. Apply the rule to both of those points and then plot your new coordinates and you can draw your new line. Or a figure like a triangle, you need to come up with the coordinates of these 3 vertices, apply the rule to all 3 of those points, plot those 3 new points and draw your new triangle between them. Or an angle, you need to find the coordinates of your vertex and 1 point on each of the rays. Then you can apply the rule to each of those 3 points, plot your new points, and draw your new angle. So let's show you how to apply the rule to just 1 point, knowing that you might need to apply the rule to more than 1 point when you are rotating a line or a figure or an angle. So the first one, rotate 90 degrees clockwise. So what this rule is telling us is that our original x, y, now we're going to put the y first and then the x, and the x is going to be the opposite sign. So if it was positive, it now becomes negative. If it was negative, it becomes positive. So first I'm going to put the y coordinate as it was, and then the x coordinate, but I'm going to change the sign. So now it's negative. Now let's rotate it 90 degrees counterclockwise. What this is saying is our x, y, now we're going to switch the places so it becomes y, x, and our y is the opposite sign. So my y is first, and it's the opposite sign, so it's not -4 anymore, it's +4. And then I put my x. Now let's rotate it 180 degrees. What this rule is saying is our original xy, now I leave it in the same spot, but my x is the opposite sign, my y is the opposite sign. So the 3 isn't now negative, it's not positive anymore. The 4 isn't negative, it's positive. And so that is rotated 180 degrees. Now let's rotate it 270 degrees clockwise. So this is saying our x, y now becomes yx. So you switch the spots, but the y is the opposite sign. So I start off with my y, but it's not -4 anymore, it's +4. And then I put my x. So 270 degrees clockwise. And lastly, 270 degrees counterclockwise. So this is saying x, y. I'm going to switch my x and my y, so it's y and then x. And my x is the opposite sign. So I'm going to put my y coordinate first, as it is, but the x coordinate is now negative, the opposite sign. So this is the point rotated 270 degrees counterclockwise. Now, you may have noticed some similarities between these rules, between the 90-degree rotations and the 270-degree rotations. So I just want to explain that for those that are interested. So if I have this red point here and I rotate it 90 degrees clockwise, each of these is 90 degrees. So all the way around is 360 degrees, 90 plus 90 plus 90 plus 90. So when I rotate it 90 degrees clockwise, then that means I'm going here. I'm going to end up right here, okay? But I could have instead gone 270 degrees, so 90 plus 90 plus 90, that's 270 degrees, counterclockwise. And I would end up at the same exact point. That is why this one is the same as this one. Okay? And for the same reason, if I rotated this 90 degrees counterclockwise, this way, I would end up here at this point. And notice that I could have also taken that point and gone 270 degrees clockwise. So 90 plus 90 plus 90 is 270 and ended up at that same point. So that's why this one is the same as this one. You end up in the same place.